Lesson 6, I will multiply two-digit multiples of 10 by two-digit multiples of 10 with the area model. So let's think about what this is saying first of all. So it says a two-digit multiple of 10. So two digits obviously has two digits, and it says it's a multiple of 10. So that means if I'm counting by tens, then I would say a multiple of 10. So we're going to be multiplying numbers like 10, 20, 30, 40, etc. These are two-digit multiples of 10 by two-digit multiples of 10. So that's what we're going to be doing in this lesson. So you should have had some practice of this in your Zern lesson. If you skipped the Zern lesson, you need to go back and do that now, please, before you get started with your practice on your problem set. All right, so we're going to go ahead and write our name, and we're going to take a look at the directions. Represent the following problem by drawing disk in the place value chart. So we've got 20 times 40. So before I can come over here and just start doing 21s, I want to think about what 20 means. Well, 20 means 2 tens times 4 times 10. Now there are lots of other ways that you could have broken this down. You could have said 4 tens times 2 times 10, which would be 40 times 20, but they chose to do it this way. Either way would get you the same answer. All right, so let's start with 2 tens. So I'm going to come over here and I'm going to put my 2 tens. I'm going to draw a circle around it just to know that this is a group, and I'm going to multiply this times 4. So that's 2 tens times 1 times 2 times 3 times 4. So I've got 20, that's 20, 4 times, or 20 times 4. So 20 times 4 would be 80, right? Now I'm going to take this whole group and I'm going to multiply it by 10, which means I'm going to move it to the hundreds place. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So I had 8 tens. I multiplied it times 10, and now I have 800. All right, let's take a look at number 2. Now we're going to use the same problem, 20 times 40, but we're going to draw an area model. Now I'm going to begin by thinking 20, which is 10 times 10. So I'm going to draw a rectangle first. And I'm going to divide it in half this way. So I've got 10 and 10, which is 20. And then I'm going to do 40 along the side. So I'm going to divide this into 4 parts. So I have 10, 10, 10, and 10. So up here I have 10 and 10, which is 20, and here I have 4 tens, which is 40. Well, we know from the area model that 10 times 10 is equal to 100. So each of these would be equal to 100. So how many hundreds would I have? I would have 1, 2, 3, 4, 5, 6, 7, 8. So 2 tens times 2 tens, 2 times 4 is 8, and 10 times 10 is 100. So 2 tens times 4 tens equals 8 hundredths, which is equal to 800. All right, let's take a look at number 3. This time, I'd like for you to try to draw an area model to represent 30 times 40, and then let's come back and see how you do. Okay, so when I got ready to draw my area model, I thought to myself, well, 30 is 3 tens and 40 is 4 tens. So I drew my rectangle, and then I divided it into 3 tens going across the top and 4 tens going down the bottom. If you did 4 tens across the top and 3 going down, that's still the same. It doesn't matter. It's just this rectangle turned on its side. So I knew that I had 100, 100, 100, 100, 100 in every one of these boxes. I did not write 100 in every one of these boxes, but I knew that 3 tens and 4 tens was going to be equal to 12 hundredths because there's 12 boxes and each of them would have an area of 100. So that is 1200 or 1200. Okay, let's take a look at number 4. I'd like for you to try to do number 4 all by yourself, and then let's come back and check this one together too. When I got ready to draw my area model to represent 20 times 50, I thought to myself that 20 was equal to 10 plus 10, and 50 was 5 tens. So whenever I drew my area model, that's the way that I drew it. I drew 2 tens across the top and 5 tens going down. So again, I still know that 10 and 10 makes 100. So each of these boxes would have a value of 100. So if I went through and I counted all of the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that would tell me that 5 tens times 2 tens is equal to 10 hundredths. 20 times 50 is equal to 10 hundredths or 1,000. Now hopefully you're smart enough to start figuring out a pattern. I'm not going to point it out to you just yet, but eventually this model is going to go away and you should be able to solve just by looking at the number sentence. Okay, so we're going to rewrite each equation in unit form and solve. So again, there's not going to be a model anymore. We're going to take the model away and we're just going to look at the number sentence. So 20 times 20 is the same thing as 2 tens times 2 tens. So hopefully in our last couple of problems you started to notice that we took this number and we multiplied it together. 2 times 5 is equal to 2 5s, which is equal to 10. And 10 times 10 is always 100. So let's apply that to what we have now. We have 2 tens times 2 tens because 20 and 20 are each 2 tens. 2 times 2 equals 4. So 2 tens times 2 tens equals 4 hundredths, which is equal to 400. I'd like for you to try to do these last 3 problems by yourself. If you get stuck, you can always press play and I'll walk you through it. Okay, so let's take a look at problem number 6. So first of all, I took 6 tens times 2 tens equals 12 hundredths because 6 times 2 is 12. And 12 hundredths is also 1,200. So let's take a look at 7. So we had 70 times 20, which is equal to 7 tens times 2 tens, which equals to 14 hundredths or 1,400. And then last, number 8, we have 70 times 30, which is 7 tens times 3 tens, which is equal to 21 hundredths or 2,100. All right, let's take a look at number 9. If there were 40 seats per row, how many seats are in 90 rows? So I just read the problem. So we have R, D, W, W. Now I'm going to draw something. Because we've been drawing area models in this problem set, I'm going to draw an area model. I could also draw a place value chart, and I could show that 40 times 90 is what it's equal to using a place value chart too. But I think I'll go ahead and do an area model. Even though it says 9 rows, I'm just going to make it a little bit smaller. I'm going to make it a little bit longer than it is taller, and I'm going to do 4 tens this way for 40. So this will be my 4 tens. And then I'll do 9 tens this way. So that's 2 boxes, 3, 4, 5, 6, 7, 8, 1 more, 9. Okay, so each of these will be 10. So this is 9 tens across the top. And then I have 4 tens across the side. So 10 times 10 is equal to 100. So now I'm ready for my number sentence. So 40 times 90 is 4 tens times 9 tens. So I have to know what 4 times 9 is. Well, 4 times 9 is 36. 10 times 10 is 100. So 40 times 90 is equal to 3,600, which looks like this. That is my number sentence. So I read the problem, I drew an area model, I wrote a number sentence. Now I'm going to write my answer as a statement. If there are 40 seats per row, how many seats are in 90 rows? So I'm going to say 3,600 seats are in 90 rows. Okay. 1 ticket to the symphony costs $50. How much money is collected if 80 tickets are sold? Okay, I'd like for you to use the RDWW process to solve this problem by yourself. And then we're going to come back and check together. Okay, so the first thing I thought to myself is I have $50 for each ticket, and each ticket cost I got $50 for each ticket and I'm selling 80 tickets. So that's going to be $50 80 times, or 5 tens 8 times. So I decided to draw an area model to represent that. And you can see here I've got 8 tens 5 times. So each of these boxes would have a value of 100. I didn't write 100 inside each of those, but that would be 50 times 80, or 50 80 times, which is the same thing as 5 tens times 8 tens, which is equal to 40 hundredths. And if you didn't know 5 times 8, you could count by fives 8 times, or you could count the boxes. So 40 hundredths is equal to 4,000. So how much money is collected? I would say $4,000 is collected if 80 tickets are sold. Expensive tickets, aren't they? Okay, so that is the end of problem set for lesson 6. So today we multiplied 2-digit times 2-digit multiples of 10, and we learned that there are some patterns that you can see. This is how you model it, but we learned that we could solve this problem without the model too. So remember that whenever you get ready to do your exit ticket.